Hi guys, this is Mrs. Allison. Today we are going to talk about graphing in standard form. So let's go over the steps that we need to be able to graph. You can follow along on the note sheet if you have it in front of you. Otherwise, you're going to need to write these steps down. So, standard form. Standard form for a quadratic equation is the equation y equals ax squared plus bx plus c. Okay, we're going to use that information to be able to graph a quadratic. So the first step is to actually list what a, b, and c are. I think this is a vital step. Remember that when you list a, b, or c, you need to take the sign that goes with the coefficient, okay? And then let's talk about what a tells you. A is the number, not the variable, just the number in front of x squared. So a is this right here. This is a. And a tells you one of two things. If our a value is a positive number, the graph is going to be facing right side up. If a is a negative number, then the graph will be upside down. We are going to use this information just to check to make sure that our graph looks the way it's supposed to look. All right, the next step is to find or calculate rather our axis of symmetry. Remember, a parabola, a quadratic function, is symmetrical about a specific line. That line is called the axis of symmetry. So the equation that we're going to use is the equation x equals the opposite of b divided by 2 times a. Sometimes we read that negative b over 2a. Sometimes we read it the opposite of b. Remember, in math, opposite means one is positive and one is negative. All right, the next step is that we are going to find our vertex. And to find our vertex is going to be an ordered pair. And this ordered pair is going to start with the axis of symmetry, which we're going to abbreviate AOS, as the x value. And the y value, the value that goes in for y, is going to be what we get when we plug in the axis of symmetry to the equation. I'm going to abbreviate equation and solve for y. I don't know what happened to that 4. So that is how we find our vertex. We find our axis of symmetry. Then we take the axis of symmetry and plug it into the equation to solve for y. Finally, the last step that we have in graphing standard form is to find our next points. We need more than just the vertex to know what the shape of this graph is, if it's how quickly it's going up or down, and just where this parabola is headed. So, to find your next points, because we know the graph is symmetrical, what we're going to do is we are going to pick an x value that is either to the left or to the right of the axis of symmetry and plug it in. Oops, I ran out of room. Plug in. All right, so let's go to the next page and let's try a problem. Okay, so we are going to look at the equation y equals x squared plus 2x plus 3. So our first step is to actually list what a, b, and c are. and I'm going to do that. The A value, change to a bigger pencil, is 1. It's 1 because the number that happens to be in front of the x squared, if you see it, there's nothing there. Well, that doesn't mean 0, it means 1. So our A value is 1, our B value is 2, and our C value is 3. I like to have that visual reminder of myself about what the A, B, and C values are. Okay, so let's talk about what A tells us. In this case, because A is a positive 1, what I know is that my parabola, because A is positive, my parabola needs to be facing upright. Okay, so if for some reason, once I get my vertex and then I find my next points, it shows that it's facing down, I know something's not quite right. All right, next thing I'm going to do is find my axis of symmetry. So that is the equation x equals the opposite of b over 2 times a. And for our problem, we know b is 2, so it's going to be negative 2 divided by 2 times the a value, which is 1. So I have negative 2 divided by 2, which equals negative 1. Lost the negative sign. Negative 1. All right, so now I'm going to come over to my graph. And I like to make the axis of symmetry a dotted line. Those aren't quite to scale, but that's okay. I like to make the axis of symmetry a dotted line. So I am going to draw a dotted line at x equals negative 1. And if we remember Hoyvux, we remember that a vertical line is an x equals equation. So there's my axis of symmetry. Let's see if I can't fix that point. Okay, so here's my axis of symmetry. So now what I'm going to do is I'm going to find my vertex, and I know my vertex is going to be an ordered pair that has the x value of negative 1. Remember, the vertex is on the axis of symmetry. Okay, so I am going to take negative 1, and I am going to plug it every place I have an x in my original equation. Here's my original equation. I'm going to substitute in the negative 1. There we go. So now I'm going to do good algebra. Negative 1 squared happens to be 1, plus 2 times negative 1, which is negative 2, plus 3, which gives me negative 1 plus 3, which is a positive 2. So my vertex is the ordered pair negative 1, 2. I'm going to do that. I'm going to put a dot, and I am going to do that dot in red for this moment. So I have vertex at negative 1, negative 2. Okay. Oh, sorry, negative 1, positive 2. Now on to the next points. We know that my graph needs to have half of the parabola on the left side and half of the parabola on the right side. So in order to do that, I need to pick a point that's either just to the left of the axis of symmetry or just to the right of the axis of symmetry. So that means I'm either picking negative 2 or 0 to plug back into my equation. Okay, in this case, I'm going to choose 0. I think 0 is going to be an easier number. So I'm going to go back into the same equation that I've been working with, and I am going to substitute in 0. The nice thing about substituting in 0, it's really easy. Now I can get y equals 0 plus 2 times 0, which is 0, plus 3. So y in this case is going to be 3. So one of my other ordered pairs is the other ordered pair 0, 3. Okay, I'm going to put a dot at 0, 3. Oopsies. There's 0, 3. And then I'm going to mirror image it to the other side of the axis of symmetry. So I should have 3 points that look nice. Nice shape, symmetrical about the axis of symmetry. And now I'm going to connect them using a nice smooth curve. We should actually try to connect them. Yep, didn't get any better. But you get the idea. Now we have the way to graph standard form. So we listed what our A, B, and C were. We determined what A told us, found our axis of symmetry, and used that to find the vertex, found a point on one side of the axis of symmetry, and then mirror imaged it over. Hopefully this helps. Thanks, guys.